In March 2023, a Bulgarian developer named did something nobody thought was possible. He took Meta's llama model, designed for clusters of high-end GPUs, and made it run on a MacBook. No Python, no Torch, no cloud, pure C++. Before llama.cpp, running an LLM locally was a nightmare. Install Python, Torch, CUDA, Toolkit, Transformers, Accelerate, and then pray that version conflicts don't destroy everything. With llama.cpp, download the binary, download a GGUF model file, run it. That's it. The secret sauce starts with GGUF, the file format that puts everything in one place. A single GGUF file contains the model architecture, context, length, embedding size, though with its full vocabulary and all the quantized weights. One file. No scattered. Now here's the magic trick that makes llama.cpp feel instant or memory-mapped files. Normally, loading a 35 gigabyte model means reading all 35 gigs from disk into RAM. That takes up to a minute. With the OS treats the file on disk as if it were already in RAM. Pages load on demand. Startup takes less than 1 second. But what if your GPU can't fit the whole model? That's where layer-by-layer GPU offloading comes in. The flag lets you choose exactly how many layers go to GPU. The rest stay on CPU. An RTX 4090 with 24 gigs of VRAM can fit about 55 layers of a 70B model, giving you 5 to 8 tokens per second. Apple Silicon users, llama.cpp has you covered. It was one of the first projects to offer first-class metal support. On M1, M2, M3, and M4 Max, it uses the GPU cores through Apple's Metal API, no CUDA needed. A MacBook Air M2 with 24 gigs runs 7B models at over 20 tokens per second. Building from source is straightforward. Clone the repo, run, and you get a suite of powerful binaries. Llama for interactive chat, Llama Server for an OpenAI-compatible API, Llama Bench for benchmarks, Llama Quantize for converting models, and more. The real game changer for developers is the built-in API server. Launch Llama Server, point it to your model, and you get a fully OpenAI-compatible endpoint. Your existing OpenAI Python code works with zero changes. Just swap the base URL to. Let's talk real performance. There are two numbers that matter: prompt processing, how fast the model reads your input, and generation, how fast it produces tokens. Prompt processing is parallel, so GPUs dominate. But generation is sequential, making memory bandwidth the bottleneck. Llama.cpp didn't just enable local inference, it spawned an entire ecosystem. LM Studio, GPT-4All, and more are all built on top of it. When someone says, "I run models locally with," under the hood, they're running llama.cpp. Want to try it right now? Here's the 5-minute setup. Option 1, install and run Llama 318B. Option 2, install llama.cpp directly with Brew and download a GGUF model from Hugging Face. Either way, you'll have a full language model running on your machine in minutes. No cloud, no API key, no subscription. Let's recap the practical takeaways. Llama.cpp made local AI accessible with one binary and one model file. GGUF is the self-contained standard format. Gives you instant startup. The flag controls GPU offloading for any hardware budget. And the built-in server gives you an OpenAI-compatible API for free. Next up in this series, Episode 11, versus VLLM versus TGI. Llama.cpp is the engine, but what's the best car built on top of it? We'll compare them head-to-head for local, production deployment, and everything in between. Subscribe so you don't miss it.